Hello, everybody, and welcome to this Connect with Helix webinar. My name is Mark Walters. I'm a member of the SEAL team here at BMC. I've been with BMC for almost 25 years now. I've worked in IT, customer support and engineering, and in my current role, I've been focusing for the last couple of years on the Helix on-prem releases, particularly the Innovation Suite and ITSM. The topic of today's webinar is the pre-installation environment checks that you can run, in fact, that you should run before you start a Helix on-prem deployment. One of the big differences between the new versions or the current versions and the older versions is that now there are only two installers that you need to run to set up and configure all these environments. One for the Helix platform for the common services, and one for Helix Innovation Suite ITSM itself. Compare that to previous versions where you had to run multiple installers on multiple systems to get an environment up and running. We're going to be working from the deployment checklist that's now included in the documentation. This runs us through many of the different components that are necessary in the infrastructure, the pieces that you need to have in place before you start a deployment. As I just said, we now only really have two installers that do an awful lot of work as part of the installation process. So the preparation really is key to a successful deployment. You need to make sure that everything in the environment is ready and prepared so that the installation can run through without issue. If you do encounter problems, it's likely you may have to go back and start over. Not all of them are easily recoverable, or the amount of effort it will take to undo what's done. Maybe it's often easier just to restart, and that again is one of the advantages of now of just having the two installers, is that it's fairly easy to reset an environment and just kick off the installation again. This is the agenda for today. It's quite a bit to get through. What we'll try and do is, for each of the sections, I'll explain maybe a little bit about the topic, why it's necessary, and where possible, we'll try and give you some example commands that you can use to actually do some validation and make sure that the components that you've got installed are ready for use. Right at the end there, we've got the health check tool that automates many of the tests that we'll be looking at. But I think it's helpful, or I hope it's helpful, to actually dig into detail a little bit for each of the individual sections, because if you do get to the health check tool stage and maybe you get an issue, you have some reference or you have some context to help you go back and have a look and try and understand what the problem might be, rather than just having to sort of troubleshoot from scratch. So we're going to start off with a quick review of the new architecture, the containerized architecture, and the different components that we're using. They are very different to the previous generation of releases, which was server-based. Some of you will probably, or some of you I'm sure will have seen this content before, so we're not going to spend a lot of time on it. The Helix on-prem deployments today require a Kubernetes cluster. So whereas previous versions ran on physical servers or VMs with an operating system, Windows or Linux, or for those of you that remember Solaris and the other Unix variants, we no longer deploy directly or install directly onto those. Those systems have been repurposed to act as nodes in a cluster. Each one of those nodes runs some Kubernetes software, and together they form a cluster. Applications are no longer installed from individual setup programs. BMC does all that work for you and provides you with a set of container images. The applications are packaged as part of those. Those are deployed into your Kubernetes cluster, and they are run as what are called pods. So the diagram on the right there tries to show a little bit of that. The yellow boxes are worker nodes, and on those nodes you have a pod, and then within the pod you have one or more containers in which the applications are running. The master node or control plane node is used to help coordinate the software across the different worker nodes, to schedule the pods, to make sure that the application pods are configured and run on nodes that have the required resources. Obviously, if you're deploying something like the Innovation Suite platform container that needs 12 to 16 gig of RAM, you need to make sure that your environment has that, or the node that's used has those resources. And that's what the control plane or the master node does. Another thing to note is that when a pod is deleted or shut down or killed or shut down, it's removed from the system. It's completely deleted. So pods are, you'll hear the phrase ephemeral. They're created from scratch from the container image every time they're run. So you always get back to a known good state. Um, but it is important. It has implications, of course, for things like log collection. If you need to get information out of a pod before you shut it down. You're probably also familiar with the deployment architecture. We have two namespaces. So namespaces are the sort of logical separation, logical dividers between components in a Kubernetes cluster. Everything that runs within a namespace is segregated. So you can have duplicate namespaces running the same applications, but they're siloed to provide some protection and isolation between the different namespaces. So we have the Helix platform namespace at the bottom there. This diagram also includes the ITOM components, so BHOM, BHCO, for example. Those are optional, and if you're just installing the Helix platform for ITSM use, you only need what's called the common services layer. So that's the portal, tenant management system, and then underneath that, the data layer. Postgres, for example, is used by the RSSO single sign-on system. So it's just the bottom two layers in that Helix platform namespace that are required for Helix Innovation Suite. Outside of the Kubernetes cluster, we have, on the left-hand side, we have the deployment engine. We'll see some screenshots later on of the Jenkins tool that's used for ITSM deployment, but we're not going to be going into a lot of detail from that. On the left-hand side at the bottom, we have DNS and load balancer and the Ingress controller. So these are some of the key network components that we need to look at. And then on the right-hand side, we have the Innovation Suite database, which lives outside of the cluster. Discovery is not relevant because we're not talking about BHOM at this point specifically. And then we have the block storage, which is where the data that needs to be persisted across pod restarts needs to live. So as I said a moment ago, when a pod is killed or when a pod terminates, it's deleted from the system. So any data that's part of that pod would go with it. So block storage and persistent volumes provide a way to protect data and make it available across pod restarts. So we're going to start off by looking at the Kubernetes architecture itself, the container orchestration platform. BMC supports quite a few now, different flavors of Kubernetes. Whether you want to run on-prem, an on-prem cluster, so you deploy your own Kubernetes or OpenShift, for example. Rancher, Tanzu are, again, just flavors or management interfaces that sit on top of Kubernetes. All of those there run Kubernetes and just have a different interface or some different features that help differentiate them that may be suitable or better for your environments. We also support public cloud. So Oracle, Amazon, Google, you can deploy to systems running in those environments. The system requirements documentation details all of the different versions of Kubernetes that we support. It's a constantly moving target. I think it's the highest version at the moment is version 1.2.7 of Kubernetes, version 4.1.3 of OpenShift. But as I said, it's constantly changing. One of the key characteristics of the containerized world is that these software versions, particularly the platforms, the orchestration platforms, they upgrade very frequently, maybe as often as 3 or 4 times a year. So the BMC product releases, we're constantly updating those to work with the latest versions. Once you've got your platform in place, your chosen platform, the next thing you're probably going to want to worry about is the sizing. At the moment, BMC uses what we call the t-shirt sizing. So we have a compact, small, medium, and large, and they're based around the number of concurrent users that you expect to run on your system. The compact deployments are, we say it's not highly available. It's single pods for some of the services rather than multiple pods for high availability. So compact is only really suitable for POCs and maybe test environments. And then small, medium, and large are what we consider production ready. We give the number of resilient and maximum concurrent users. So the idea of the resilient users is that allows for maybe hardware failures or changes during upgrades, for example. So that's you should always be able to run that many of users, that number of users. But the systems will be capable of peaking the maximum concurrent users if they're in when they're really busy. If you're doing a more complex deployment, maybe your numbers of users fall outside of these, are very different, or perhaps you have an environment where there's a lot of integrations, or something that's not typical user activity, or if you're combining BHOM or BHCO, one of the other ITOM products, with an ITSM instance. Make sure that you check in with BMC, raise a support case, and we'll be able to give you some customized advice on exactly what's needed in terms of the CPU and the RAM for your cluster, for your environment. So the cluster hardware, the nodes, as I was saying, BMC, we're fairly agnostic in terms of the container runtimes that you use on your cluster. That will largely be dictated by the version of the flavor of the container orchestration platform that you're using, whether it's Kubernetes. OpenShift, for example, has a different set of requirements about what you have to configure on the nodes. The container runtime is the component that actually allows the container images to run. Docker is a common one, but there are others. Containerd, CRIO is another one. For the master or control plane nodes, you have to have at least one, regardless of the size of your cluster. But again, that's not considered HA, so wouldn't be suitable for production use. You need at least 3 for production and high availability, and that allows for it allows for avoiding what's called the split brain problem. So each one of these pieces of software works independently, but between them they manage the cluster, and it allows you, having 3 allows you to take one down for maintenance, for example. So make sure that your system remains up at as much as possible. We don't provide a specification for the master nodes. The reason being is we don't really know what else you might be doing on your cluster. If you're running other workloads, or you're using a particular version of Kubernetes or the container orchestrator that has different requirements. So follow your vendor's recommendations as regards the hardware specification for the master nodes. For the workers, you're going to need at least 4. One of the reasons for that, again, or the main reason for that, is high availability. During upgrades, some of the services that we deploy have what's called pod anti-affinity. That makes sure that where you have multiple pods of a particular type, that they're spread across your worker nodes. So if you can imagine a system where one of your critical pieces of code was running in 3 or 4 pods and they all got scheduled on the same node, if that node failed, you would end up with a service outage. So the pod anti-affinity allows us to spread those across the nodes, and we need an extra one during upgrades to make sure that a new pod can be created. You need at least 150 gig of disk space on each of your worker nodes. That's for the storage of the actual container images themselves, but also for what's called pod ephemeral storage. So when a pod is created, it's allocated a chunk of file system space from the node, and that's what it uses as its temporary working space. So temp files, maybe some log files, for example, would be created in that ephemeral storage, and that's released and reclaimed when the pod is deleted. And then the combined available resources across your worker nodes must meet or exceed the numbers that were given on the previous slide for the sizing. So if you were to pick a compact deployment, I think which is 29 CPUs, your 4 worker nodes between them must supply at least that amount of CPU. How you divide it up across the nodes, again, follow your Kubernetes documentation or your own best practices. What's important is that you have at least the amount of free space and CPU available, free memory and CPU, to meet the sizing that you've chosen. There's a few tools that you can use, or a few commands that you can use to review your system. So kubectl is the primary command line tool for working with Kubernetes. If you haven't already started working with it, you'll get very used to it. OpenShift has its own version, I think, called OCP, but they're pretty much compatible in terms of the command type arguments that they take. So you've got commands that can list the nodes that you have in your cluster. So you'll be able to see things like the software version and the container runtime in use, which are the workers and which are the control plane or the master node. kubectl top node, so that shows you what's currently in use in terms of CPU and memory on the system in real time, so useful perhaps for performance troubleshooting. You can customize the output of the commands. So in the third example there, we're using a JSON type output, which is showing us the free resources on one of the worker nodes. So in this case, the node W01 has got 16 CPU, 130 gig of free memory, I think. Sorry, free disk space, and then it's a 64 gig system. So that's useful to help you confirm that your worker nodes all meet the requirement. And then there are also some third-party tools. One that I like is one called kubecapacity that has a number of options, including that -a there, which shows you what's available. So when a workload or a pod is deployed to the system, ideally the pods should all include resource declarations. So it should have as part of its configuration, it should include information about how much CPU it needs to run and what the maximum CPU it will consume is, and the same for memory, a minimum and maximum amount of memory that the pod needs. So here you can see that the system is pretty lightly loaded. Most of the pods, most of the nodes have got most of their resources free, and that's because it doesn't yet have a system deployed to it. So that's useful to make sure that your cluster is appropriately configured. Next thing we need to move on to is the persistent storage. So as I mentioned earlier, pods are ephemeral. The file system that is created for them when they're run will be deleted and lost when the pod is terminated. So we need, particularly for things like databases, you need some way of retaining information across pod restarts, and that's where persistent volumes come in. So only the Helix platform uses persistent volumes, at least directly. The Postgres, Redis, Kafka, these are all key components as part of that namespace, part of that installation, and they all create their own persistent volumes. Each pod will have its own, and the total amount of storage that's needed is approximately 1.7 terabytes. So whatever storage system you're using to provide your storage class, your PVs, your persistent volumes, you need to have at least 1.7 terabytes worth of disk space available. It won't all get used immediately, and some storage systems do allow you to over provision. So you don't necessarily have to have that much physical disk space at day one. The pods will only, not for all storage classes, and the NFS storage class is an example of one that does allow you to do this. You can declare a persistent volume size that is larger than your physical disk space that you have available. Obviously, that's okay maybe for a compact system which you're using for test and development. For production, you want to make sure that you've got enough space available. The kubectl command, again, you can use to have a look and see what storage classes you have available. Storage classes are the providers, if you like, of the persistent volumes, and there are many available. we use, or not, sorry, use BMC recommend or have tested a thing called Ceph, which is a very high performance block-based file system. Longhorn is another one that's quite popular, and then we've got NFS again, which is maybe helpful for test and development systems. And BMC say we support a bring your own storage model, so we don't have any particular requirement on a specific type of storage or a specific implementation. What's important is that it is sufficiently performant to meet our requirements. And again, this is all in the documentation. We recommend that you use solid state disks where possible due to their very high performance, low latency and throughputs. If you can think, you can have dozens of pods running on a particular node. And if they're busy, there will be or could be very high throughput. So it's important that you have a high performing disk subsystem. There are two types of storage really within Kubernetes, one called read write once and another called read write many. Read write once is the main one that's required by the Helix products. It's only, I think, bhom monitor requires read write many, and the difference is a read write once is dedicated to one particular pod, so only one pod at a time can access it. Read write many allows several pods to concurrently access it, and there's a requirement, I think, in the smart graph component of bhom which requires that. But we give you the performance numbers in terms of latency and throughput that you need to be able to do that, or be able to do a deployment. And there are plenty of tools out there that you can use to validate and test that your subsystem, your disk system meets those requirements. So two examples provided here, Kbench and kubestr. They're freely available on the internet. There are links to their downloads pages and website. In the references at the end, and they'll deploy a test pod into your environment, and it will run a series of read and write tests to give you the numbers that you need, the IOPS and the read and write throughput to make sure that your disk system meets the requirements for the products. Container images are that the BMC provides the products as need to be stored on a registry server. So you need to be able to get the images from BMC into your environment and into your cluster. There are a couple of hundred, I think, images almost in total that you'll be needing or be using during a deployment. Not all of them run permanently. Some of them are job containers, job images that do integrations and configuration of the products as they're actually installed. The documentation includes Harbor as an example. Harbor is a very popular registry server. It's fairly easy to set up. I think the BMC documentation actually gives an example of how to do that, but it's not the only one. We have customers using others such as Artifactory and JFrog, and there are many others. What's important, what you should try and do, is to set up a local registry server. So BMC have a public registry server called the BMC DTR, Docker Trusted Registry, that's connected to the internet. And whilst you can do an installation directly from that, we strongly recommend that you set up your own registry server on premise and locally, and that's close to your cluster. The reason for that really is performance and availability and reliability. So if you imagine, as I said, we've got several hundred, a couple of hundred container images, many tens of gigabytes worth of data that will be transferred and used during the deployment and installation of these products. And if you're pulling that directly from the BMC DTR, using that line at the bottom there as the example, you're going to need a fairly high performance internet connection and also reliable. The last thing that you want is that to fail in the middle of a deployment. So the best solution, or the recommended solution, is that you deploy your own registry server on premise. Don't pull the images direct from BMC, synchronize them from the BMC DTR onto your registry, and then it's local to your cluster and you get the best performance. The other thing to remember, and has caught a couple of customers out, is that the images need to remain available even after deployment. And the reason for this is, imagine an application, one of the containers is running on a particular node. And for whatever reason, maybe the node is restarted for maintenance, or there's you decide to restart or delete a pod. That pod may get recreated on another node. And if that node has not previously run that container, that pod, it will need to fetch the image from the registry server again. So you should treat the registry server as a critical part of the infrastructure. Some customers, for test and develop sort of POC deployments, maybe they've run a Harbor server actually on the deployment engine, where Jenkins and the deployment manager script for the Helix platform are run. That's fine as a short-term solution, maybe if the environment's only intended to be around for a few weeks or a month or two. But certainly for production use, you need to make sure that you have a reliable and high-performance registry system. The documentation includes lists of images that you need to synchronize to make sure you've got them all available before you start. There's a push to repo script that's part of the documentation that you can download. I think it's also included, or a version of it included, in the Helix platform installer, and that will take a list of images from a file that you can download from BMC and copy them from the BMC DTR and push them up to your own local registry server. There's another script called the image manager that I'm responsible for, that's available on the communities in a blog post, that has a few more options, allows you to synchronize directly, or to, if you're working in an offline environment, perhaps your cluster is air gapped and you need to download those images and save them and then physically transfer them to a different system before uploading them. The image manager can help with that. SSL, almost all the container runtimes that you'll come across will default to expecting that your registry server is secure, that it has an SSL certificate. So this means there's a little bit of setup on your part to make sure that SSL certificate is configured within the container runtime that you're using. So whether that's Docker or Containerd, each one of them has their own individual process for configuring these certificates. So you won't find the details of how to do that in the BMC docs. Please refer to the documentation for your own container orchestration platform as to how that has to be configured. It is possible to run the registry servers as insecure registries, but again, that will almost certainly need some additional configuration on the cluster side. It's not part of the BMC product configuration. It's part of the infrastructure that you need to get ready before you start a deployment. You can use the Docker command line tool to help do a bit of validation. So make sure that you can log into your own registry server, validate your credentials. Make sure that you do that from maybe from the deployment engine and also from the nodes on your cluster, to make sure that all the connectivity is in place and that the certificates are working as expected. And there are also commands. So the bottom example there, manifest inspect, allows you to validate if an image exists on a registry server. So perhaps once you've finished synchronizing everything you want to run through and check that you've got them all, you can use a command like that, or you can use, say, the image manager that I mentioned earlier has an option to do validation based on a list of files. Something else that you'll need, another external server, usually is a mail server. So as part of the Helix platform installation, an email is generated which has an activation link that you need to click on. So you need a way to receive that email. So and also the health check tool, when you get to run that, one of its pre-checks is to send an email to make sure that connectivity is up and running. So you can use your company SMTP server, assuming that it is accessible and you're allowed to use it. We support the use of SSL and different authentication methods for connecting to that mail server. It's configured through the product pipelines. and the infra config file for the Helix platform deployment. You can set those options. If you don't have a mail server, or again, maybe this is a POC system or something like that, and you're only doing it temporarily, you can run, there are a number of options for running your own server. So Mailhog, Mailcatcher, they're available either as applications that you can run or as container images themselves. So you can run them using Docker on the deployment engine would be one way to do it, or you can deploy them as a pod in your cluster. And you just need to make sure you have the correct sort of names to reference the services, and you'll be able to receive your email. So the screenshot there on the right hand side in the background is a Mailhog interface with the activation email. That has the clickable link where you can set the password for the HANA admin user. And you can also use things like Telnet to make sure that you can talk to your SMTP server. If it's secure, that may or may not work, but there are many tools available. Use the ones that you're familiar with, or the ones that are appropriate for your environment. An area or a topic that's caused, I think, quite a bit of confusion, and is certainly is new for most people when they come to the Helix containerized releases, are the Ingress requirement, the Ingress controller requirement, and the use of a load balancer in front of the system. So apologies for the colors. It's my best attempt to try and explain how all of this works. So on the top left there, we have a client. So that's typically it's going to be a browser that you're using to access one of the services. There's some kind of DNS query that's run for the different product host names that are registered and required as part of the Helix setup, and that we'll get to in a moment. They all resolve to your load balancer. The load balancer then passes through the traffic to the Ingress controllers running in the Kubernetes cluster, and the Ingress controllers, they match the URL that you've requested, so the host name and the URL that was requested by the browser. They check that against a list of Ingress rules that they have configured that are set up as part of the product installation. Both the Helix platform and the Helix ITSM create a number of Ingress rules, and those Ingress rules match the requested URL to a particular pod and service that's running the application. So the load balancer takes the request, passes it on to one or more of your Ingress controllers. The Ingress controller then matches it against its rules and sends the request off to a service, and then hence to the pod to actually be worked on. You can you need to install, or you're responsible for installing the Ingress controller. The versions that we support vary depending on the version of Kubernetes. Again, the current up-to-date list of supported versions is part of the system requirements documentation on the BMC website. You have to use Ingress NGINX. There are others. OpenShift uses a thing called Roots. I think there's an NGINX Plus as well. At the moment, we only support Ingress NGINX. We're looking to extend that, and future versions may add others, but you will need to set up and deploy that, and there are steps in the documentation that explain how to do so. Once it's up and running, check to make sure that the namespace exists. So kubectl getNS will list all the namespaces running on your system, and typically you'll see an Ingress NGINX one for the current version. Have a look at what's in that namespace. You should have a combination of config maps, services, and actual pods or daemon sets. Depending on the size of your cluster and the configuration, there'll be multiple pods as part of the daemon set. So make sure that everything's up and running and that there are no errors there. If there are problems, you're going to need to go and troubleshoot maybe the configuration of the system. So you can validate it, or you can go and do that using a config map. Have a look at the config map and the daemon set. BMC recommend that you install NGINX as a daemon set rather than a deployment. The difference there is the daemon set will run one pod on each node by default, which helps with high availability. Whereas a a deployment, you get to set the number of pods that you run, and you have less control, and unless you get into configuring into the configuration details, you have less control over where they're run. A daemon set is more straightforward in that it makes sure that there's one pod on each of your nodes, and then your load balancer can be configured to use to redirect traffic across those nodes. So have a look at the configuration. Again, the documentation includes some specific settings that you need to enable or change for optimum performance. So they're usually stored in the config map, and then the daemon set has a couple of settings that you need to be aware of. One is to do with the SSL certificate. We'll talk about this in a little bit more detail shortly. But if you're allowing your Ingress controller to handle the SSL termination, then you need to configure it with a certificate, and also the Ingress class. It's possible to run more than one Ingress controller on a system. So again, if you're using OpenShift, you'll probably already have the OpenShift root Ingress system deployed, and I know some customers use HA proxy. There's an Ingress controller version of HA proxy. By specifying a different Ingress class for each of your Ingress controllers, you can run multiple. So you need to make sure that you know which one you're using for your Helix deployment, because both the Helix platform and the Helix IS installation parameters, you need to confirm or tell it which one you're using, so that it creates the rules in the correct space. DNS is critical. It's how the host names that represent the products are mapped, and how you find your way to the published services. So it's important that they're all set up correctly, and they also need to be included when you generate an SSL certificate. The Helix platform, the host names that you need to register are most of them are user defined. So you set them up in the infra config. So there's the LB host, the MinIO, Kibana. They're individual lines that you set, and you get to choose what they are. Whatever your corporate standards are, you can pretty much pick and choose. There is one that's automatically derived from a combination of some of the other values. So the Helix portal host name is a combination of the company name, the tenant type, and the environment that you've entered in there. So as an example, at the bottom, you can see Helix private POC is a result of the company name being Helix, the tenant type private, and the environment being POC. So it's the only one in this for the Helix platform that you can't choose yourself. So it's important to remember that you need to add that one as well. On the Helix IS side, they're all derived from pipeline values. So the three that are relevant are the customer service, the environment, and the cluster domain. And you can see there that they are combined to make the mid-tier, smart IT, and all of the other different URLs that need to be registered as part of your DNS. So all of these need to be set up in advance before you start the deployment. And you can verify that in a number of ways. You can use, for example, NSLookup or dig, a command line tool. Check each one of them, make sure that they all resolve to the same IP address. That will typically be the load balancer that you're using, that's sitting in front of your cluster. Make sure that everything resolves to the same place, and then you should be good to go on the DNS side. And say keep a note of them, because you also need to make sure that they are registered as hosts with your SSL certificate that's needed. There are a couple of tests that you can run to make sure that the Ingress controller is up and running. It's a little bit counterintuitive, but you do get an error from the Ingress controller even when it's correctly set up. And the reason for that is that at this point, before you've started an installation, there are no Ingress rules available. So what will happen is you can use a tool like curl, for example, to query your different host names that you've registered in DNS, and what you should get back is a 404 error. But what's important, you can see there, is it's coming from NGINX. So that confirms that your request was correctly routed through the load balancer and into an Ingress controller it didn't have a matching rule for the host name that you've requested, so it returns an error. We're using the -k option with curl just as a note there to disable SSL at this point, again, because you can configure curl to use a certificate file, but at this point it doesn't really matter whether SSL is working properly or not. What we're really trying to do is just make sure that we can get through to the Ingress controller. You can also deploy a test Ingress application. So there's a common one, the apple and banana Ingress test. There's a link there if you want to go and download it. That's a simple YAML file that you can use to do the deployment. And then you can use curl to make sure that you get the appropriate response. SSL onto the next part. All access to the applications that are running as part of the Helix deployment use SSL externally. So they're all HTTPS based host names that route you to your load balance and then into the Ingress controller. But you do have a choice as to how that SSL is handled. So the two main choices, and apologies for the complexity of this, I hope it makes sense. So in green at the top there is you have the example where the load balancer is handling SSL for you. So some customers prefer to do this for performance reasons. The load balancer, maybe if it's something like an F5, has dedicated hardware that can be used to process SSL and do the encryption stuff, which means it may perform better than if you let the Ingress controllers do it, and it takes the load off your cluster. So your client makes an HTTPS request to the load balancer. The load balancer is configured to decode that, and then it passes on the request to the Ingress controllers using straightforward HTTP. And then the Ingress controllers route the requests to the services. The other way is SSL pass-through. That's the red one underneath. So again, the client makes an HTTPS request to the load balancer, but the load balancer just passes it straight through to the Ingress controller, and then the Ingress controller is configured with the SSL certificate to do the decoding. And that was one of the configuration items that we noted in one of the earlier slides for the daemon set. That's where you have to put the certificate into the Ingress, into a secret in the Ingress NGINX namespace, and then you configure the Ingress controller to tell it where that certificate is. So those are the two choices. There are some other variations in reverse proxies and some of the X forwarding. There's documentation has a little bit more detail, but really you'd probably take advice from your network infrastructure team as to what's the best way to do this for your company. You'll need to get an SSL certificate. A couple of different ways of doing this. If you have your own company CA, certification authority, you can request certificates from them. You can buy them from commercial organizations like DigiCert and some of the others, or you can generate self-signed certificates. Self-signed might seem attractive and maybe is useful for a quick test environment, but one of the things to remember is if you're using self-signed, you need to distribute that certificate to all of your clients, or they have to be configured to trust or ignore that certificate, which can be a bit of a nuisance. So commercial, custom, CA and self-signed are supported. The certificate itself, there are two choices. You can have a wildcard certificate. We've got in the upper example there. Many companies, particularly for production environments, may have restrictions that prevent you from using wildcards. They may be considered a security concern, so you might not be able to do that, in which case you'll need to create a certificate where the subject alternate names, or SANs, are set. So there are multiple SAN entries in your certificate request that cover all of the different Helix product host names that are created from the previous slides. So it's I think it's probably about 20 in total. And we have a bit of a habit as well, BMC, of introducing new ones. Of course, with new product releases, if we add new features, you may need to add one of those. So be aware that this is this isn't necessarily a one-time step. The certificates themselves will have an expiry date, and you may also at some point in the future need to generate new ones. So there's a number of ways that you can validate that the SSL certificate that you've received or that you've requested is what's needed. So the OpenSSL command should be available on the deployment engine where you're going to be running the installers for the Helix products. So you can use that to print out the contents of the certificate. And the previous screen there, actually some of those screenshots that was where the output was captured from. So you can use OpenSSL to actually work with the PEM file itself. Once you've got the certificate configured on your environment, you can use curl with a CA cert option to tell it which custom, which PEM file to use, which certificate file to use, or you can use OpenSSL to connect. And those commands between them, what you're looking for is that you're not seeing any errors. What you want to see is that the connection was established and secured, and that there aren't any obvious errors, and that will give you confidence that you've got the right certificate and that you've put it in the right place. And there's any amount of troubleshooting you can do, obviously depending on the type of error you get, but that should at least give you a start. And then also, if you're for the ITSM installation, we use a Java CA certs file. So there's a freely available tool called SSL Poke that you can download and use, and that's helpful on the Java side to make sure that your CA certs file that you'll be attaching to the Jenkins pipeline when you do the ITSM deployment has the correct certificates in. Next up is the Innovation Suite database server. So unlike the Helix platform, where the database is running internally and use persistent volumes and pods within the cluster, the IS database server has to be external. BMC support, as with the earlier versions of AR system, we support SQL, Oracle, or Postgres as the database. It needs to reside on a system which is external to your cluster, so either a physical or virtual machine. Different versions of the database supported: Oracle, SQL, Postgres. These, of course, will vary or change over time as new versions of the product are released. But I think those are the current supported minimal versions. If you're using SQL or Oracle, you must restore a backup, a database dump that the BMC provide for you and you download from the EPD. If you're using Postgres, you can download a backup and set it up manually, or there's an option within the installation pipeline that will actually do the restore step for you. So some customers prefer a little bit more control over how the database is created. Perhaps you have a dedicated database team that will do that for you. So in which case, even if you're using Postgres, you may choose to do the manual backup and restore. Sorry, the manual restore. Limited tests that you can run. What I would say is use a suitable database client. So SQL Plus, pSQL, or SQL Command for MS SQL, or one of the GUI tools, one of the GUI management tools that these products provide. Connect to the database as the AR admin user, or whichever user you're going to be using for the IS installation, and make sure that the database is there and you're able to query some of the tables. So in the examples there, just checking the version from the control table. We're looking at the users that are in the user form and doing a count of the number of forms in the AR schema table. So all of those queries use data from the AR system, the IS database. So that will help you understand and confirm that the database dump has been restored correctly. And avoid problems when you come to run the platform IS deployment later on through Jenkins. The health check tool is now, again, like the deployment checklist, is part of the BMC product documentation. It's a very useful tool developed by one of my colleagues on the SEAL team that helps automate many of the tests that we've just looked at. So certificate validation, mail server, persistent volumes, DNS resolution, resource requirements, lots and lots and lots of things. It's a very useful tool. It's available, or the same tool that can be used for both the Helix platform and for Helix ITSM. It's a shell script that you can run on the deployment engine, and it takes the parameters from the for the infra config and deployment config that you're using for the Helix platform, for example, and allows you to will run all of its checks, and it'll print out a pass or fail, a number of errors, number of warnings, produces a log that allows you to go and see what might have failed. There's a article on the communities which shows you how to, which will walk you through modifying the Helix on-prem deployment pipeline to allow you to save all of the values for that, for the innovation suite deployment. And you can then also do IS validation, as well as the text-based log output. There's a set of web pages that summarize the information. So I can't really stress strongly enough how important it is that that you take advantage of this tool. It will be, if you do have an issue during installation and you end up raising a support case, one of the first things the support team will probably ask you to do is to run the health check tool. So it will catch 90% of the common misconfigurations or things that you maybe have overlooked as part of setting up the environment. So it really is important that you run it and validate and make sure that it says that the environment is ready and that there are no errors. There may be one or two warnings, particularly around sizing, where they don't match up, that you can check with BMC if you're concerned. But what you want to make sure of is that there are no errors, that everything passes in that sense. One of the things that might be useful after you've run the health check tool is, if you do have some errors, is you may need to troubleshoot some connectivity issues. For example, perhaps one of your pods wasn't able to connect to something. So one of the things that some of the tests that the health check tool runs is it deploys pods into the cluster, and they will attempt to connect to the mail server and send a test email. They will also, in the Innovation Suite case, will attempt to connect to the database and log in using the credentials that you provided in the pipeline. Perhaps you need to do some checks there to make sure that the name resolution is working properly. So you could deploy a test pod. So the example here is using CentOS as the test. Create a test pod within the cluster, and then you can actually get a command prompt within that pod, and you can install additional tools, NSLookup, ping, telnet, all of those networking type troubleshooting tools that you may be used to using on external systems. You can add in and you can run tests to make sure that everything established. Maybe you don't have proper connectivity. So I've seen a couple of cases where customers had firewalls between their cluster and external systems, and they hadn't opened the correct ports, for example, for the database. So this will allow you to perhaps to troubleshoot that, and then you can just delete the pod once you're finished. There are some specific checks that you maybe want to run after you've deployed the Helix platform. In fact, for a couple of them, you have to have deployed the Helix platform first before you start the Innovation Suite installation through Jenkins. First thing that you're going to need to do after installing the Helix platform is to create an RSSO realm for your Helix IS system to use. So this is done through the RSSO admin interface. The important thing to note here is the tenant ID on the left-hand side. On the left-hand side there, the helix.number. So in your environment, the Helix bit will be the company name from the infra config, and the number is generated automatically each time the installation is run. But that tenant ID is used in several other places. So make a note of that. You need to create a realm. You can see there the tenant name or the tenant ID is that helix.number from the previous screenshot. So that's the first place that it's used. Here you need to enter all the Innovation Suite URLs. that are used for RSSO authentication, and the name of the realm ID at the top there is also important. That should be customer service -environment from the pipeline parameters. So that's how the when an RSSO request is routed into the system, when you log in for the first time, that's how that's the method that's used to match your request using the URL and the realm to send it off to the right authentication source. So it's important that that's done correctly. And then within the pipeline, when you come to do the IS deployment, you'll see the tenant domain at the bottom there. Again, that's the third place that Helix Helix.number is used. So it'll be different. Every environment will be different, but what's important is those three places you use the same value. Within Jenkins itself, there's a setup script now that does almost all of the work for configuring Jenkins. There are a few manual steps still, but it's still helpful to go through and validate where possible that the installation has completed. So three things I would recommend that you check. First one is the agents or nodes. So once you've finished installing, there should be 3 agents configured. The built-in node, one which is the name of your machine on its own, and one with the Git prefix. The reason there are multiple nodes is a sort of a historic reason to do with the fact that the pipelines are also used for BMC to do their SaaS deployment, which obviously is run at a much larger scale. So there's some built-in flexibility there, which means we have these different nodes. So you should make sure that those 3 nodes exist within Jenkins, that they're all online and available for use. The next thing to check is in the Jenkins, if you go to the Manage Jenkins list and scroll down the page that's there, you get to a section called the Global Pipeline Libraries. There's a few more parameters that need to be configured than are being shown on the screen here. There's an SSH as a link to a Git repository is the key piece. But what's important is the bit that's highlighted there. That currently maps to revision. The number doesn't matter. What's important is that it looks like that you have a revision number. If you've made a mistake with the either with the SSH URL or perhaps with access permissions, something like that, what you'll see there is an error. So make sure that both the pipeline framework and the Jenkins workaround library, there are 2 libraries configured, make sure they both show revision numbers, and that will give you some confidence that the SSH setup that the Jenkins system uses is correct and configured and working. And then the final thing within Jenkins are the credentials. So these are the various usernames, passwords, kubeconfig file that are used during the pipeline execution. So make sure that all of those exist and that they are correctly set with the passwords. Again, that the details are in the documentation. There's an extra step in the Jenkins side to do with SSL certificates. So you need to download a CA certs file from BMC, and you need to add into that CA certs file your own certificates. And that CA certs file, it's a Java key store, is then used during the installation process. And it's configured as I think it's a secret in the Helix IS namespace, and the various pods that require connectivity via the load balancer, they have to have that certificate available to be able to make secure connections. So the way that's done is by using this CA certs file. What has happened, or what I've seen happen at a couple of customers, is that they create an empty CA certs file or a new CA certs file and just add their own certificates. And that will cause a problem because the downloaded CA certs file includes a specific ES node certificate that's required for FTS to work properly. The Helix Innovation Suite IS server uses an Elasticsearch service running in the Helix platform as its data source for indexing and searching full text search information, and that is a secured connection. And for that to work, you must have this this out of the box downloaded from BMC CA certs file that has this specific ES node certificate in, and it's this file that you add your own certificates to. So use something like the key tool command there, list the use the alias ES node, and also use the alias for when you've added your own certificates to the file, you will have given them an alias. So just double check and validate that all of those certificates are present. The certificate fingerprint isn't important. What matters is that that certificate actually exists within the CA certs file. If it's not there, you will have a deployment error later on. These are obviously all the references, the tools, the kube capacity, kubestr, test ingress, for example, that were referenced earlier on, may be useful for you to be able to use and run in your environments. There's a set of BMC communities articles there talking about how to use kubestr, the image manager script, and also how to run a temporary SMTP server. And then finally at the bottom there, the actual Helix product lists. There's a dedicated Helix containerization platform on the BMC communities. If you're not already a member, strongly recommend you go and sign up. There's no conditions, there's no fee or anything like that, but it's a private group that you just need to request membership of, and customers have discussed issues there, and at BMC we post blog articles and other useful information. So it's a very helpful resource. I recommend you have a look at that. Right, thank you very much everybody. Hopefully now we have some time for some questions.